Hello and welcome back everyone to Universe Sandbox 2. This here is our favorite red planet Mars, and using the new Universe Sandbox 2 update, which adds lasers, surface grids, and realistic water flow, we are going to terraform Mars, and we're going to make it beautiful, and we're going to take total advantage of the fact that we can do so many fancy things now. We are going to laser the poles of Mars to heat it up, and this is Elon Musk's dream right here. This is it. Elon Musk, please share this video, and I would like a Tesla. Tesla would be my dream car, so thanks. Thank you, Thank you, Elon. I highly appreciate it. So, didn't mean to do that. In the update, we can see in the surface thing here, we can see this chart, which I will expand for your viewing experience. Can I zoom? Oh, I can. Here we go. So this is the heat distribution on Mars. So we can see that that one spot is 5,000 degrees, and the rest is like 40 degrees, and then it goes all the way down to negative 152 at the poles. So we are going to heat things up so that the water melts and we can start creating some beautiful, beautiful oceans. Okay, let's go ahead, grab our laser. We're going to turn down the power so that we don't absolutely fry everything we touch. There we go. Okay, so let's do some cleaning. We're going to remove the poles. Actually, if we found a way to do this, this would actually be pretty efficient, because if you use a laser to terraform Mars, you don't actually have to transfer anything. You don't have the weight problems you have with moving anything else to Mars to terraform it. We just shoot the laser from Earth. And then again, if we had a laser this powerful, it would probably ionize and really mess up our atmosphere on the way out of Earth. But we could build a space station orbiting Earth that shot lasers, and it would be much easier to fuel that. We could put a fusion reactor in it. Fantastic. Okay, so now we've got the basis of our idea. So the average surface temperature is negative 139. Oh, no, negative 13.6. The lowest is negative 139. And what we're going to do is we are going to greatly increase the size of our beam. We're still going to do... Okay, that made the wattage go way higher, so let's go ahead and switch it back to... Oh, that's not what I wanted. 2 exawatts, but we're going to cover the entire surface of Mars in our 2 exawatts. So, what we're going to do by doing that... Okay, we may have went a little bit too big. That's still the entire planet. There we go. Okay. So now we can spread the heat out. And that's not quite enough. Oh, it killed our power. Okay, so let's do 5. Yes, I did run around my apartment cheering. It's been so long since the channel has been doing well. Okay. So let's go ahead and heat this up. You can see right here in the average surface temperature that this is a very large laser we're shooting. It's about the size of, well, Mars. But if you use a certain type of refraction and very well calculated mirrors, you could spread a small beam out. You would just need a ridiculous amount of power. So now the average surface temperature of Mars is rising rather quickly. We've got it at a cozy 10 degrees. We're gonna get it to like 24. I think 24 will be doable. It's like baking a cake. You want the nice like gooey center, but you don't want to burn the entire thing. It's not at all like that, but Aaron is in the other room, so I have to make it about baking somehow. Okay, so now that we have done that, it is time to begin giving the true essence of life. H2O. Now, last time I discovered that there is a beautiful new system for water. Water physics. I love it because City Skylines, pretty much, I am famous for doing stupid things with water, and now I can bring that into yet another series. Now, look at this. When we put the water back on, it actually, we can see that it's going frozen up here, but it'll probably melt because we changed, I think the heat just has to travel. Hopefully the planet isn't cooling back down. Let's see. The average surface temperature is 23. Oh god, we made a lot of the surface way too hot. This is all like 100 degrees. Whoops. Okay, so this is freezing and the rest is boiling. So just like in real life, it's a little bit challenging to use a laser to do this. Whoops. So we're gonna shrink this and we're going to decrease the amount of power by like 1/5. Okay, so now we're going to heat this up so that it's not frozen. It's a lot of balance, honestly. Gotta be very careful. This does not seem to be working. It seems to actually be bringing more ice. Whoa, what is going on? Oh, it's negative over here. What? I'm so confused. Okay, let's kick this up to 10 exawatts. There we go. There we go. That's melting the ice cap. So it looks like we just didn't get enough energy. Okay, now the ice cap is way too hot, but better too hot than too cold, because the heat goes down over time. And you can see actually the frozen areas don't have atmosphere because the water, the clouds actually freeze and solidify on the surface. Very interesting. Here we go. So now we've got most of the planet is around boiling now, but there's spots of it that aren't, whichever parts I didn't overly fry. It's hard to cook when your stove turns off. That's true. That's true. Okay, so let's go ahead and grab the material and see if liquid water is able to be seen. Oh, come on. I think it's just too hot in these areas for it. Let's find a spot where we can see the liquid water. Okay. So I think we're gonna have to manually pump a little bit in until we just start to see it, just to saturate the ground first. So let's saturate the ground. But after we saturate the ground, we can actually choose where we want to put our oceans. That's one of the really cool new things. We get to choose where to put the water. Obviously, if we flood the entire planet, we're going to, well, not choose where to, like, right there, see? But a little bit too much. But now, I'm pretty sure that if we just add a little bit, enough to make it come off the surface. Okay, let's turn the rate up to 200. No, we're not quite there. One more. Oh, okay, you know what? That's good enough. That's good enough. So now, we're gonna choose where we put an ocean. First off, let's melt all this ice, because this ice looks nice. This nice looks great. This nice ice, this nice ice is giving me lice. Okay, there we go. There we go. Okay, we've yeeted the ice. Okay, where do we want to put our ocean? Lice equals ice. Very nice. Okay, where are we putting our ocean, guys? Should we put it like in the North Pole? That may suck though, because it'll freeze. Let's put it in this little area right here. These like really deep areas will hold the water well. So all we have to do is sprinkle the water down, and it should fill in the lower elevation areas. And it'll spread out a bit. And here is the first ocean on Mars. We'll see how it spreads out to the areas that are lowest in elevation. It's draining a little bit. I think, oh, is it gonna get blocked by anything? Mars is so flat, we may actually have an issue here where the water just spreads over the entire surface, because it is very, very flat. Okay, it seems to be calming down. It's filling all of these craters. Ooh, it's pouring over into the north over here. Oh, look at that. That's so neat. I love, and look, it's retreating back now. Oh, the water physics looks so nice. I love it so much. Honestly, this This has got to be the biggest update there has been to this game in a long time. Here we go. And it's stabilized, and now we have built our ocean. So the question is, what else can we do with this? I was wondering if the land can also get higher. So what we're gonna do is we're going to jump onto tools, we're gonna jump onto material, and silicate. So let's go ahead and find a big part of the ocean. Ocean, come back. My water's gone. Oh God! The water left! Why did it leave? Probably because we're at a terrible temperature. Absolutely terrible temperature. 90, 92 degrees. The surface is too hot. The water boiled away. I am very depressed now. Okay. So let's try this again. We will get our ocean area. We're gonna actually stop Mars from turning. It's just gonna make life a lot easier. Probably screw up whatever, I don't know, there aren't really seasons because there isn't like anything to have seasons. Well, I mean, there's a tilt, so I guess there's seasons. It's just they don't mean much. Okay, so once we can see the area we want to put the thing on, rotational period, boom, pretty much infinite now. Okay, now we can add water. Let's build our ocean again. Ocean man. Okay, we're gonna give it a little bit of time. Look at the ocean spread over. Oh, I love it. I love that so much. Okay, so it's all pouring up north, just like it did last time. We have a little bit of a system here, though, going through. But we're gonna add more water because it's being absorbed into the ground, and we want to have beautiful oceans. There we go. That's pretty good. I'm pretty happy with that. Is it just gonna slowly disappear? It's leaving. Like I said, it's a little bit too hot. But you know what? We'll just go fast. My question is simple, and it should be able to be answered even with it being a little bit silly. There are actually cities in Universe Sandbox. Okay, so what we're gonna do is we're going to grab the one question I have about this is, can we build land masses in an ocean? Actually, yeah, okay. So let's go ahead and grab silicate and see if we sprinkle a little bit of silicate down. Unfortunately, it looks like no, we cannot just like build land. Oh, that's sad. What about iron? I really doubt that would work. Okay, so that answers that question. Well, we did figure that out. So the question is, in this new world where now we can control the oceans and stuff, can we successfully, stably terraform Mars? So let's go ahead and jump into the solar system now that we've done our testing. We're going to go ahead and grab Mars. And first off, the laser is just going to be a little bit too much. So we will use lasers for localized stuff, but for the major thing, we need to just bring Mars closer to the sun. It's just how it got to be. So we're gonna bring Mars really close to Earth. We're gonna reorbit it. Where's the auto orbit button? Auto orbit, there we go. Null reference exception. Yay, we found a bug. That's exciting. Okay, let's see if Mars heats up at least its average temperature now. Okay, average surface temperature on Mars is now in the -20s, which is a lot of progress. Negative 18. We're gonna have to bring it in a little bit closer, I think. Yeah, okay. A little bit closer. A little bit closer. So let's go ahead and grab our edit again. Bring things in. Now we're very close to Earth. Dangerously close to Earth, but that's fine. Once again, we've got an error. Should probably report that to the Universe Sandbox 2 team. And we are getting... Oh! We're going to be in the positives. It'll no longer be literally freezing. Okay, I guess we're bringing it a little bit closer than Earth. Because the Earth has a massive blanket. Haha, reference. The sun is a deadly laser, but we've got a blanket. Anyways, we've got our blanket which holds in heat. Mars does not have that quite yet, although we'll probably have issues once we do add it, so we don't want Mars to be too hot on its own. Like 5 degrees works. We just want it to not be too freezing. 7 degrees? I think we're gonna even out at around 10 degrees, I think. We can actually, Universe Sandbox 2 has this really nifty graph thing where we can see if it's actually getting higher every cycle. And it is getting a little bit higher every cycle. Oh, maybe not. It's fluctuating back and forth. That's interesting. I wonder what's causing that. Huh. It's going up, but it's so slowly over so many years that I don't think it's something we really have to worry about. Okay, so now water, liquid water, can actually form on parts of the surface. And this new surface thing here is going to let us know exactly where. So, wow. Wow, the range in temperature on Mars. The side facing the sun is 255 degrees, and the side not facing the sun is 200. Wow, that is some detail. I didn't even think of the sun making it hotter on some parts, and the poles are very, very cold. So we really do need to balance this out, and the best way to balance this out is going to be increasing the atmosphere. Let's increase it to 1 Earth atmosphere. So this is going to immediately cause some issues. Mars is going to heat up now. Whether we want it to or not, it's about to get very toasty. And we're going to see this red spread very quickly. At least I believe so. This should average out the temperature though, so you can see that the over here, actually I can pull this and make it a little bit bigger as well. I don't want to cover the entire screen with this, but it is interesting to watch. So the did that really not make much of a difference? We gave it an entire atmosphere. Wait a second. Are you telling me that made no difference? Really? Okay. Huh. Maybe it'll take a little bit for the blanket to start being effective. I don't know. It does look like... No. I definitely see that the average temperature is turning more green. So the atmosphere is definitely getting things a little bit less radical. Although it's going back and forth. Honestly, what's going on? This is really easy. Okay, so how are we going to solve this problem? We can change the average albedo, which will actually have a huge difference. That would be changed. That would be very difficult to change in real life, but the higher that is, the more heat we're reflecting, which is going to cool it down. I guess we're gonna let more heat in and see what happens. The big question is, how do we get the heat to be more balanced across. Like, that is going to be the big challenge, balancing the heat. Okay, guys, do we have any ideas? I have an idea. Okay, hear me out. I wonder if water would help. Water would probably help a little bit. How are we going to do this? But we were to use a really big ice cube. Big brain moment. Big brain. Like, if we look at Earth, I mean, Earth obviously has differing temperatures as well. But the lowest is -12 and the highest is 52. Mars is just totally extreme. We have -179 and 300. And the atmosphere should actually help. Oh, you know what? If we make the atmosphere into a way more of a blanket, right? And then we move Mars closer, I think that'll balance it out. Okay, so let's let Mars cool down with its new blanket. So it's gonna get cold. So like the low temperature should get lower, and it's moving, it's decreasing. 200. Okay, it's still pretty bad, but we're making some progress. Let's just turn it up to what? 80%. This is a little bit ridiculous, but I guess you got to do what you got to do. Okay. So, we are now going to go sub 100 degrees, and now the possibility of life is actually increasing rapidly. Because the water isn't boiling off the surface, but it's still too hot. Now the poles are still super cold. But if we let time go on, 30 degrees, 20 degrees, this is now doable. This is now doable. Okay, we can work with this. So Mars is a little bit funky looking. The poles, which are quite large, are very cold. And for some reason, one side of Mars has like a bigger area than the other. But ignoring that, we should be able to add water and get an ocean in the parts that aren't frozen. So let's see what happens. Let's go ahead and grab our material tool and throw water onto Mars. A lot of water onto Mars. Like we're gonna go a lot. Can I not increase the amount? Here we go. Times 10. Oh. Okay. So the surface grid system is now functioning, and you'll see that the water is actually going up. It's flowing up to the poles and freezing there. But if we continue supplying water to Mars, just continue supplying it, so the poles are now filling up with ice. That's fine. We don't need the entirety of Mars to be survivable. We just need sections that humans could survive on. Looks like the Pepsi symbol. And actually, through a little bit more rainfall, artificial rainfall that is, and a little bit more time, we are getting areas that are habitable. I think a little bit more water is in order. Here we go. So not perfect, obviously, because a lot of Mars is still frozen. But we can see a little bit going on here. Make an atmosphere first. We did. We added 1 atmosphere of pressure, which should be perfect for humans. Yeah, 1 Earth atmosphere. I don't know why it's not really working, though. and I can't see it, but there is certainly an atmosphere. It probably is just some work that has to be done. Anyways, this, although not pretty, this is going to be peak performance. Not perfect, but what we could do is we could get a little bit of help from our friend Space Laser and just yeet the ice away. Just quick pulse of laser beam whenever things freeze. Make sure we evacuate the area first. I like how the ice doesn't move, but once you melt it, it becomes water, which moves, so you have to, like, chase it. There we go. And we will... So yeah, it is viable to terraform using lasers in this version, which is super cool and super exciting. And the terraforming itself has gotten a lot more complicated, but I like that. And it also means, the update means that you could potentially create a giant lava theme park on one side of Mars. Let's set this to 1,000, 1 zettawatt. Look at this. Here's our lava theme park, and the rest of the planet's fine. Even though the atmosphere has been expelled, everyone's gonna be okay. Beautiful. Absolutely beautiful. Okay, guys, well, thank you for watching. I think that we've learned a bit of terraforming in this new version, and I will see you all next time. Goodbye, Mars. We're gonna heat you up real nice. Real nice, Mars. Look at the heat. Look at the love we are giving you. The amount of energy we're putting into this relationship. If you don't literally melt your significant other with the intensity of your relationship, you're not doing it right. Wow, we're turning Mars blue. Come on, come on, come on, vaporize. I don't think this laser is strong enough to completely vaporize Mars, which is a little bit disappointing. But we are like shooting the surface of Mars off. We're ionizing the top layer of Mars. It's like skinning an onion. Oh, we've hit the temperature. There we go. We've done it. Fantastic. Good job, guys. Now we're going to shoot the sun. But the sun ignores our laser. That's sad. Next time, we will shoot lasers into a black hole, because why not? Wait a second. Oh, it would be so cool if the laser deflected the beam. Like, 1 second. I need to know. Oh, wait. Black hole's going to eat the entire solar system. That's fine. That's fine. But will the black hole bend my laser? No. That would have been so neat if I put the... Oh, I thought it did for a second. I put it like here and it bent back around at me. No, no light bending. That's sad. Well, thank you all for watching. Leave a like and subscribe if you enjoyed. We will do more in the future, and bless all of you Vooperians. Bye!